All right, in this video, we are going to be taking a look at the power rule for derivatives. And this is really just a shortcut. All right, this is a shortcut for all the stuff that we were doing last night with that limit as h goes to 0 of f of x plus h minus f of x all over h. All right, so we were using this yesterday, and we still definitely could use this, right? And this is our limit definition. Limit definition of the derivative. And we remembered, well, what does this do for us? This is just going to gives us an equation for the instantaneous slope at x. All right, and when we want to find it at a specific x value, such as x equals 3, you just plug in 3 for x, for whatever you get for the derivative. So let's just run through a quick problem for that now. All right, the first thing we need to do, of course, is find f of x plus h. That is going to be equal to 3 times x plus h squared plus 4 times x plus h minus 5. Now, if you do all of that out, we should get 3 times x squared plus 6hx plus 3h squared plus 4x plus 4h minus 5. All right, once you do the foiling and distributing, boom, that's what you get. So now as we take the limit as h goes to 0 of f of x plus h, so 3x squared plus 6hx plus 3h squared plus 4x plus 4h minus 5. There's my f of x plus h. Now I want to subtract f of x. So minus 3x squared minus 4x, because remember I need to distribute that minus sign, that minus f of x, and then plus 5. All over h. And in the numerator, everything that doesn't have an h in it should cancel out if I did it correctly. So let's just check and make sure. My negative 3x squared cancels with the positive 3x squared. My positive 4x cancels with the negative 4x. Negative 5 cancels with positive 5. So now I've got the limit as h goes to 0 of all this stuff over h. Well, I do that division, and I'm left with 6x plus 3h plus 4. And that's the limit as h goes to 0. Well, when I evaluate that limit as h goes to 0, this term is going to go to 0, leaving me with just 6x plus 4. And now that is a lot of work to find an answer that we are going to learn a new method to find it in just a couple of seconds. All right, and it is really important that we understand this method. That's what the derivative comes from, is finding the slope, and then as those 2 points get infinitely close together, what is going to be that instantaneous slope. All right, so what is the power rule? Basically, what the power rule allows us to do is just take the exponent, or the power, and we will multiply it down in front, and then just subtract the power by 1. So 3x squared becomes 2 times 3, which is 6. Okay, this 6 right here. Times x to the, well, power goes down by 1, leaving me with just x to the first power. And then with 4x, that 4x to the 1 multiplies down in front, and the power then drops by 1. Well, x to the 0 is just the same thing as 1, so we can write that as just 4 times 1 is just 4. All right, so for the power rule, if we have some function f of x is equal to a times x to the n, okay, the derivative of that is we are just bringing down the n, so multiply by n, and then drop n's power by 1. All right, so the derivative would be equal to n times a times x to the n minus 1. All right, let's see that in action with this example. This would take us forever if we use the limit definition of a derivative. However, using the power rule, I'll just multiply 4 times negative 5 gives me negative 20. And I drop it by 1, so now it's x cubed. Then multiply by 3, I get 18x. Drop it by 1 gives me squared. Then multiply by 2, I get minus 6. X to the first is just x. And then I multiply this one by 1 and x to the 0. Just left with 4. And then, of course, 5. Well, there wasn't any. That 5 is really just going to disappear. You could think of it as being 5 x to the 0 power. Well, if you multiply by 0, 0 times anything is going to go to 0. So you don't need to write plus 0 at the end, right? So boom, it makes these problems infinitely times. Not infinitely times, but this problem could have taken us up to about 10 minutes to FOIL everything out, distribute, and then actually use the limit definition of a derivative. The power rule makes this incredibly quick, and it becomes a problem that we can really do in, I don't know, 10 seconds, 15 seconds. So it makes our lives a lot easier. All right, hope you enjoyed the video.